Okay, so the next two lectures, you're very lucky. You're getting actually a sneak peek into our keynote address for the conference. Both will be related to infrastructure and service delivery, which is going to be the main theme of the conference as well. So hope you enjoy it. And first up, we're going to be listening to a lecture from Prof. Turner. Thanks so much.
Thank you. So welcome. So everybody, make a list of the 5 most important things that your city government does for you. 5 most important things your city government does for you. Just think about it for a minute. So I'm going to put my list up in a little bit. All right. So this is about infrastructure delivery. It's about really going to be about sewers, but I gave it a bigger title. So So the problem that we have is that so like everybody came a long way to be here. Everybody is pretty excited to be here, right? Yeah. So how excited would you be if we were all in your backyard? Not very, right? So so the problem that we face is that we want to be close to each other when we work, right? But not so much at other times. Right? And so the way we solve that problem is with cities, all right? And as soon as you state the problem that city solves in that way, you immediately start doing what Gabriel did, and you start thinking about getting back and forth, right? And that cities are sort of this combination of, we're trying to satisfy this need or whatever. We're trying to exploit whatever benefits we have from working at high densities, while avoiding the discomfort of that in our houses, right? And we're going to try to accomplish that in some least cost way by going back and forth as best we can, all right? And that leads you right away to sort of the two sort of organizing questions of urban economics, which is, why are we more productive when we're together, and how much, all right, which is agglomeration economies, right? And then how does the cost of cities affect the way that the cities are organized, right? Which is like any urban model has got transportation costs front and center, right? But having stated the problem that way, it's clear there's this third thing that's really important, which is our willingness to tolerate density. Right, and so because this is a room with, reasonably comfortable chairs close together, with this nice structure so you can all see it in the back, so we can work together in a group of however many people this room will fit, right? Which is, we have all of this physical infrastructure that lets us function at density, right? And so the other question, which is clearly pretty central to how cities are organized, is what are the things that affect how we tolerate density, right? And so these two things, right, are really studied, and this one is just not. Like, that is one that has kind of gone under the radar, right? And so that's what I want to talk about today, all right? And in particular, well, all right. So now as to these lists, all right? So if you think about the list that you made, so here's my list, all right? So if you think about the things that you need in order to tolerate density, if you don't have drinking water, you're dead in 3 days, all right? Or sick, right? If there's too much law and order, if there's too much civil disorder, right? If there's too much, you can't function, right? So you have to go somewhere else, right? If you don't have sewer service, like, use your imagination, density gets pretty ugly, and so on, all right? And so the rest of my list is all of this stuff, right? And so what I want to think about is like, there's an agenda, which I'm going to start today, which is sort of measuring, just as we have measured the way that transportation infrastructure, the availability of transportation infrastructure, affects the density of cities, right? We measure the way that the availability of drinking water, the availability of fire protection, and so on, affects the way cities are organized. Does it facilitate people being close together or not? Right? And so this was my list of most important things. You guys, has anybody got anything that they think should be on here? Yeah. Yeah. So electricity should be on there. Transportation should probably be on there too, like sort of the ability to get around. But like I'm leaving that off in a category by itself. Housing, yeah. So and housing for sure. I would have. Yes. Okay. So all of these things are things that sort of contribute to our ability to like tolerate being close to each other, which is a substitute for having to live far out in the suburbs or not live close to people at all. Okay, so I'm going to talk a lot about what I'm going to do is like this. There's a book to be written here, right? Which I will die before I write it probably. No, yeah, I will. I see you shaking your head, but right. And so what I would like to get to is, so what I want to not do, right, is I don't want to tell you how great sewers are, right? Because from a policy point of view, I don't think that's very helpful, right? What I want to tell you is how great sewers are compared to something else, right? Is I want to try to lay down the foundation for comparing the value of sewers. So if you are the mayor of Cape Town, no, okay. And you have $1 to spend, all right? What's the effect of spending that dollar if you spend it on each of these things, right? And what is the social value of that, all right? So I want to lay down the foundation of that. So if I just tell you that sewers are great and they have all of these really good effects, I'm not really informing that decision, right? Because at the end of the day, the mayor of Cape Town doesn't have enough money to do all of this stuff or do as much of it as he or she would like. And so I want to be able to think about that trade-off. And so what the agenda that I want to push here is that each of these things, plus housing, plus electricity, plus whatever is on all of your lists, we need to be able to think about how to balance expenditure on each of those things against the others in particular cities. All right, and so the agenda that I'm going to do is I think we've made some progress on this one, right? But all these other things are open and still to be done. So to think about. All right, so with that, shoot. I did all of this, all right? So with that, the way this is going to go is I'm going to try to lay down the foundation for thinking about the implications of an investment in sewer infrastructure for the way cities develop, all right, with the idea that the values that we come up with, like the sensitivity of cities to sewer infrastructure, would be inputs into a cost-benefit analysis, right? Is $1 spent on sewers pay for itself in any sort of welfare sense? Is $1 spent on sewers a better investment than $1 spent on electricity, and so on? Okay, so the logic that I'm going to go through is a little complicated. Okay, so the first thing I'm going to do is I'm going to show you the evidence that we have for the importance of public health and how cities are organized, right? And for the most part, this is going to rely on a discussion of the 19th century U.S., which was when U.S. income was about at the level that many African countries are at now, because that's what we know, all right? All right. And then the second step is I'm going to show you the evidence about how water and sewer affects public health in cities, right? And there we'll have some evidence from the U.S. and from developing countries too, not South Africa in particular. All right, and then those two things are sort of going to set once we have those two places once we have those two pieces in place, then the third step is that public health infrastructure should affect the organization of cities directly, and then that's this paper that I want to talk about, which we've just wound up. right? So that's the plan, and here we go. Okay, so this is from World Health Organization, world availability of water and sewer. So the first thing that you have to do is you have to define availability, right? And so the World Health Organization has this sort of hierarchy of quality. So for safely managed is drinking water from an improved source that's located on premises, available when needed, and free from fecal and priority chemical contamination, right? On down to you're drinking groundwater, you're drinking water, surface water, all right? And then safely managed, this is sewage, is use of improved facilities not shared with other households where excreta are safely disposed in situ or transported and treated off-site, all right? So and then on down to worse and worse. Okay, the thing to note, the thing that I am struck by here, particularly in this one, is like, this takes in things that I would count as a pretty well-maintained campground. All right, this is not what I have in my hotel room. Right, this is not everybody has a flush toilet or flush toilets in their houses. This is something which is a well-maintained outhouse counts. So even the top rung of this ladder is pretty primitive. Okay, so with this scale in mind, here is the availability of sewers. All right, let me do water first, actually. So overall, 7 of 10 people have safely managed water service, so that's an improved tap in their house. Water's easy relative to sewers, all right? The reason is that water's easier to manage than sewers. Why? Because water travels under pressure, right? So it will go uphill, right? If sewers don't travel under pressure, it will not go uphill, right? So designing sort of piped water networks is a lot easier than designing sewer networks, right? And so what you see is this is broken out by area. Sub-Saharan Africa, 25% of people have safe water. These are people, and so on down, all right? Here's the corresponding figure for sewers. All right, which is only 40%, like sewer is harder than water, so 40% of people have, remember, this is the top rung of that ladder, which is still pretty basic, and only 40% of people in the world. It's about 40%, it's actually 40% of the urban population too. And then you can see this is broken out by area. All right, so I am a little bit suspicious of these data because of this, because I know that there are people, I know that there's sort of modern sewers in Africa, and they don't show here. So it may just be that these data are 10 years old. All right, so, but the point is that there's a lot of need for this stuff. Okay. All right. Okay, so that's availability. So now I want to think about the effects of these things, all right? And to do that, I'm going to show you 3 slides describing the history of the United States in the 19th century, all right? So this one, or so these two show the same thing, right? So the x-axis, the x-axis here is years, so 1800 to 2000. Most of these graphs that I show you are going to have that same x-axis, all right? So this one is 1790 to 2010. All right, so this is the share of agricultural employment, right, which goes from close to 80% down to 2, all right? So we had 80% farmers in 1800 down to 2% now, and this is the opposite picture showing urban employment, all right, which is, goes from, sorry, urban population, which goes from 5% in 1800 up to about 85% now, all right? So notice right about here, right around middle of the 19th century, there's this inflection point where cities start to grow really fast. I'm going to point that out in a different figure below. Okay, so this is the time, right around here, is when the Industrial Revolution started to happen in the US in the middle of the 19th century. Right? So that's when incomes really took off. Right? You can see that in this figure. All right, so this is 1850. This is per capita income, same x-axis, 1800 to 2000. So from 1800 to 2020, U.S. incomes increased by a factor of like 27. Okay, and that really started in the middle of the 19th century, right here. Okay, all through this time. Okay, the rural-urban wage gap was about 30%. Okay, so the data on that's terrible. All right, but the best I've been able to find is it seems like it's pretty constant all for 200 years. Okay, and so here is the sort of big one, right, where we start to talk about public health. So these figures are 4 different cities, all right, depending on how well you know the U.S. is Boston, Philadelphia, New York, New Orleans, right? The same x-axis, 1800 to 1900. It's a little different. This one's 1811 to 1911 and so on, but basically they're 1800 to 1900, right? And the y-axis is the crude death rate, right? Crude death rate is if you have 1,000 people on January 1st, how many die by December 31st? All right, so crude death rate of 25 per 1,000 means that of your 1,000 people that you started the year with, you lose 25. So what you see is so these spikes are what, right? So where's Philadelphia? Philadelphia. So what are the spikes? The spikes are epidemics, all right? So Philadelphia was famous for having yellow fever epidemics in the 18th and 19th century. And you can see that the crude death rate goes from 25 to 40, all right? So the rate at which people are dying in these epidemic years is about double the baseline. Right, and in this one is particularly, this is New Orleans. New Orleans is at the southern end of the Mississippi. It's the swampiest place in the country. You'll notice the y-axis is different here. So instead of 25, you've got 60. So the baseline crude mortality in New Orleans is 2 or 3 times as high as every place else, right? And then the spikes are 140. So that's 1 person in 7 died in New Orleans in 1840. Right? So these are very high and very variable crude death rates. And then, so what do you guys see in this picture? Why did I put this picture up? What do you see? Right? What do you see? Yes. First of all, it's trending down, right? It's trending down, all right? In all of these places, crude death rate trends down over this time, right? And what else? The variability goes down, right? So over the course of the 19th century in the US, all these spikes, you get to 1860, 1860, 1860, all those urban epidemics go away, all right, in all of these cities, all right? And I had to restrain myself. There's 2 more. I could have showed you 8 or 12 more of these cities, okay? But all around 1860, right, that starts to go away. So what's happening, right? Germ theory of disease, right? Water and sewer infrastructure, vaccination, food purity laws. So all of these things started to happen. There were all of these innovations around this time, right, which made it so we could live together at high densities, like in this room, and not make each other sick. All right? And that, remember the point of inflection in this figure, right, is right about here. Okay? Right? Over the same time, right, so this table, right, so what I've just showed you is these are urban death rates, right? So if we're thinking about the formation of cities, right? So these are, the pictures I've showed you don't quite match, right? This is the death rate in cities. This is the growth of cities. Most growth in cities is coming from people migrating from out of cities, right? They stop being farmers, start living in the city. So the thing that is relevant probably is not exactly the urban death rate, but the ratio of urban to rural death rates. Like people are always working off of differences, all right? And that is this table here, all right? And so this is the ratio of rural to urban crude death rates, urban to rural crude death rates by decade, right? So 1870 to 1840, it was 1.4, which means that for every 1,000 people who died in the countryside, 1,400 died in the city, and so on, right? And just as in those, and what we saw is that what we see is that declines pretty dramatically by the early part of the 20th century. All these public health innovations, right? In addition to sort of the secular decline in the growth rate, right? So what's happening is that over this time, we've got all this public health infrastructure. You can see it in the crude death rates, right? So the epidemics stop, cities get safer, in particular, cities get safer relative to the countryside. This matches up with when cities when the growth of the urban population sort of hit that inflection point, started to grow really fast, right? And also at a time when incomes were growing really fast. So all of those three things occurred at the same time, okay? Any questions?
Excuse me. Why is it not consistent? Like the years, I understand that you're using like a certain time period, but for...
So why does this one start in 1800 and this one start in 1811?
1920.
This is a long time ago. Like, the guy did the best he could, right? Like, this was really hard to do. This was the I forget his first name, Haynes. He's a serious guy. He did the best he could. Like, historians, they just go and live in libraries for 5 years at a time, and this is what he came up with. Okay. Anybody else? Okay, so these events all sort of coincided with each other in the late 19th, early 20th century. Urban population increased, productivity increased, and urban mortality rates fell, all right? So the conventional wisdom on this, all right, which is the story that I have heard ever since I was in graduate school, is that this reflects that therefore the growth in urban population in the U.S. reflects this trade-off where people move to cities to work in factories and are more productive, right? And against that benefit, they face all these problems of density, which is death, right? And misery, okay? And if you read about people's lives in the U.S., in U.S. cities at this time, the densities that people lived at were just, you would have 6-story wooden frame apartment buildings with whole families living in a room where basically there was enough room for everybody to lie down, right? And there's an outhouse in the back, right? So very high densities, miserable, everybody died. Now, who's been any PhD, we have PhD students here, right? Right, would this fly in applied micro seminars? No, not even close, right? Not even close, all right? So what's the problem is what you would like for this story, all right, what would be a good research? So if you were serious about this, right, which to my surprise, I don't think anybody really has been, like, how would you tackle this, right? What would you want, right? You would want something like quasi-experimental variation in urban incomes, quasi-experimental variation in the mortality rates, and ask how that affected migration, all right? And we're nowhere near having that, all right? So this is sort of the story that we have for urbanization in the U.S. at this time when, the U.S. economy was developing, right? But we do not have this story nailed down, all right? So we do have some more evidence for this, all right? Which I think will stand up more nearly to an applied micro seminar audience, all right? So this figure, so let's just focus on the left one. This is land rent. This is a rent for a standardized apartment in the U.S., all right? And the green line, and then the horizontal axis here is distance from the center of the city, all right? This is averaged over all U.S. cities, and this is COVID. So the green line is December 19th before COVID, right? And the red line is after COVID, all right? And so what does that line tell us? Anybody? What does that line tell us? All right. So what happened to the rent for an apartment in the center of a city, of an average U.S. city, during the period when COVID started? it dropped. So this is just the thing that you read about in the newspapers, right? Is everybody moved out of the center of New York and San Francisco, and they moved to the suburbs, right? So even now, right, with all of the public health infrastructure that we have, like disease is still doing the same thing, all right? And so this figure, right, is sort of telling us, is giving us some evidence that puts these three things together. Right? People make this trade-off between danger and productivity, and when you bump up the danger, they leave. Right? So this is, I think, some pretty solid evidence for the importance of public health for the way cities are organized. All right? Just for reference, right? In New England, where I live, COVID killed about 2 people per 1,000, maybe 3. All right. So if you look at that compared to the size of these shocks. Right, those shocks were 2 or 3 per 1,000 is just like noise in these pictures. All right, so the epidemics that were shaping these cities during this time, so that is 20. So it's an order of the public health shocks that these cities were experiencing were an order of magnitude more dangerous than COVID. Yes.
Do you know how these death rates compare with Europe at the same time and Africa today?
I think they're about the same in Europe, all right, at this time, give or take. Africa today, I have no idea. Okay, and that is the next thing I'm going to complain about, right? Is so we know a lot less about this process for Africa, right? Vern and I tried to do this, right? We tried to sort of pin down this story for developing world economies, and this is how far we got, right? We did not have this crude death rate data. What we did have is the Development and Health Survey, right? And the Development and Health Survey is this gigantic survey which concentrates mainly on women, right? Is randomly collected. It's a really powerful survey tool, right? And many of the in many of the survey waves they say, have any of your children died in the last year? Okay, right? And so we can ask how the response to that question varies with the population density in the neighborhood of the respondent. So what we did is we got for each survey respondent, they're geocoded. We said, what's the population density in a neighborhood of that respondent? Right? And how does the likelihood of an affirmative response to has one of your children died in the last year vary with density? And the answer is barely. Right? So you don't see, if you had done that same thing in the US in 1860, you would have seen this factor of 1.4, right? Or whatever, right? And in these data for the DHS waves for around 2010, you really can't see it. Okay, you can see other things which suggest that it's clear there's some things that cities are worse than in the countryside in Africa and the developing world. Women are slightly more likely to say that their children had diarrhea during the previous 2 weeks as the population density goes up. Right? People are more likely to have diabetes and they're more likely to be overweight as density goes up. Right? So there's some health things, right? But nothing that looks like you're 1.4 times as likely to die. Okay? So there's a little bit, all right? The rural-urban wage gap in Africa and in much of the developing world looks to be at least as large as it was in the US during this time. All right? So that piece is common. All right, and so I think it's an open question, right? I don't think we have enough data to reject that the same process governed urbanization in the 19th century U.S. as is ongoing now, right? But it would be nice to have a lot better evidence on this, and in particular, getting into vital statistics data and so on is something that would be really nice to do. Okay, so. So that's what we know about urbanization and income and public health in the U.S. All right, we know more. We also know something about the particular effects of infrastructure on public health. All right, and so I'm just going to go through. I'm going to tell you about a bunch of papers here. All right, so this one. All right, so there's two sets of these. There's 4 or 5 for the 19th century U.S. and then 4 or 5 for the contemporary developing world. So this paper is set in Boston from 1860 to 1920, right? And in Boston during that time, they were building out a bunch of water and sewer infrastructure. Right, and so if over this 40 or 50 year period, they built out a lot of water and sewer infrastructure with sort of, really they had 3 goals. Like the object was, first of all, to really they had one goal, is they wanted to keep water and sewage apart. Okay, like the overriding goal of this project was drinking water and sewage were getting mixed together, and they wanted to put an end to that, right? And so they moved sewer outlets so they were downstream from water intakes. They put sewers into different municipalities. They put piped water into different municipalities. They moved water intakes so they were upstream or at protected sources away from sewer outflows, right? And so what the unit of observation in this study is a municipality, so a small a municipality that is part of the greater Boston. And what they're going to do is ask what happens to infant mortality after water and sewer lines are installed, right? And what they find is that infant mortality falls by about 1/3. All right, that's 25%, all right, which at the time was falling from 150 per thousand, right? Again, from 150 per thousand. Anybody find that number terrifying? Anybody with young children? Okay, that's 1 in 7. So infant mortality is a baby that is born, does not reach its first birthday. Okay, 1 in 7. Over the course of this period, that fell to about 40. Right, from 150 to about 40, about a quarter of that drop they attribute to water and sewer infrastructure, okay? Second version of this is this paper by Anderson, where they have data on infant mortality for about 25 US cities, and they look at what happened, and they track 6 or 7 different public health innovations, water filtration, sewer installation, moving sewer outflows, moving water intakes, 6 or 7 things, right? Milk purity laws, okay? So about this is sort of before refrigeration, right? And so there was a lot of problems with infants getting spoiled milk. So what happened is that the way that they dealt with milk spoilage is because they didn't have refrigeration, they would put borax in it. And it kept the milk from spoiling, but also made it poisonous, right? And so, like, that was something that was common, and we got rules that outlawed that in the late 1800s. So this is they're going to do this, and they're going to get kind of different results, right? What they find is that the effect of managing sewer outflows on infant mortality is 0. Right? Water filtration is a win, right? The joint effect of all of the water quality related interventions is about 4%, right? So they're finding an effect of public health infrastructure, but it's a lot smaller, all right? And so these are both solid papers, right? These are both solid papers, and the confidence intervals are such that these two numbers are not the same. Like, you can't weasel out of it with confidence intervals. All right, so these are both solid papers, and that they disagree is like, it drives me crazy. Okay, I'm going to talk about that a little bit. All right, sort of making up these slides. I think I have a story, right? But like, these are both solid papers. They get different answers. I don't know why. Okay, here is a story in Chicago. What they did over time is they moved the water intake progressively further out into the lake. So Chicago is very flat. It's on a river. So the Chicago River, which is the natural place for sewer outflow, drains right out into Lake Michigan, which is the natural place for water intake, right? And so you have this disgusting cycle, which made everybody sick, all right? And so the way that they dealt with that over time is they moved the water intake progressively further out. So they moved it 2 miles out, then they moved it 4 miles out offshore, right? And so over time, what these guys did is said, what happens to mortality or morbidity at around each of these times when they move the water intake further out into the lake? And they find it falls, right? And so they attribute sort of a big part of the reduction in crude mortality in Chicago over this window, notice these are all the same time frame, to improve drinking water alone. Okay. Okay, this is Paris. All right, in Paris, completely taking a neighborhood in Paris and running a sewer line into everybody's house added a year on average to the life of a baby born in those houses. All right, 1 to 3 years was their range. Okay, a nice paper by Truskin. The U.S. has its own racial pathologies, which meant that during the early 20th century, there were big differences in black and white lifespans and expectation, and sewer infrastructure. The nature of constructing sewers is it's hard to avoid neighborhoods, right? It's hard to route them around. You're kind of stuck. And so the build out of sewer networks seems to have done a lot to narrow the life expectancy gap. Right, and if you're interested, if you're interested in knowing what historians done, this is a nice survey. Okay, so one thing to notice here, you have to read these papers really, you have to pay attention really carefully, right? This is, right, because these interventions, it all looks like water and sewer, but they're all actually different things, right? So this is, we're putting sewers into houses, we're putting sewer lines into houses. Right? This is, we're managing, these are big municipal facilities. We're building treatment plants. We're moving sewer outflows, right? This is, we're running these lines into municipalities. So when we're trying to compare magnitudes and when we're trying to think about using all this research to evaluate current things, you have to read it really carefully to find something that matches up with whatever policy you're trying to evaluate. Like if you're trying to evaluate building a water treatment facility in a city, that's a different thing than evaluating putting piped water lines into people's houses. You have to read these papers really carefully to make sure you get one that matches what you want to do. Okay. Okay, and so now on to the developing world, on the sort of modern world, all right? In Argentina, at the end of the 20th century, they privatized the water supply, right? So it had been provided by the government, didn't work very well. They privatized it, water quality went up, and they saw over the course of a couple of years an 8% drop in infant mortality, okay? Which is pretty big, all right? This paper, all right? This paper, I think, is like one of the best in the literature, right? And in the early 20th century, in Mexico, there was a national program to chlorinate municipal water supplies. And so basically they went from city to city and started chlorinating water supplies. The authors matched that up with vital statistics data, right? And could watch the death rate, the infant mortality rate fall as the chlorination hit each of these villages, right? And I bet you that I'm the only person that does that today. All right. Gave you a 50% reduction in infant mortality from diarrheal disease. Okay. Now, here, this is Brazil, about the same time, right? Looking at the rollout of piped water, all right, and sewer access by census tract in Brazil. And so they've got 30 or 40 years of data, and and the census question says, do you have piped water and sewer, and what's the infant mortality in this tract? And they're just going to look at those two things. So there's not the nice research design that this paper has, okay, right? But they are getting zeros on sewers, right? And something for piped water. Notice that these interventions are not the same. This is chlorinization, this is treating the water, and this is putting a piped water line in people's houses, right? So you're getting something off of both of those, okay? This is also a piped water thing. It's a subsidy for piped water, and what they find is that no effect on infant mortality in Morocco, right? No effect on infant mortality, all right? So here we have chlorinization, or sort of upgrading the water supply saves babies. Chlorinating water saves babies. Piped water in your house saves babies, not sewer access. Here, piped water in your house does not affect childhood incidence of waterborne disease. This is an RCT, all right? So you can't argue with that. But getting piped water, getting water is a big chore, so it has lots of other effects on people's lives, right? So fetching water is a big deal, all right? And then here, a paper by Ed and co-authors looks at the effects of interruptions. It's in a building in Lusaka or a neighborhood in Lusaka, looking at the effects on people's behavior of interruptions in piped water supply. All right. And what they find is that when there's more interruptions, girls spend less time at school, and babies are more likely to get sick. All right. So you can see that there's lots of these water interventions. Right. The water interventions look like they're important for health. Right. So here I have a summary slide. Let's do that. Okay. It looks like the interventions that improve water quality, right, are pretty solid, or at least for mortality. Okay. But there's still some variability, right? It doesn't seem to matter everywhere all the time. Like, go figure, right? That seems to work in the developing world now, and in the 19th century U.S. Okay. Just getting access to water, I think that's a little bit less clear. At a minimum, that's a big labor saver. So that really affects people's behavior because they don't have to carry water all the time. The evidence for the provision of sewers is mixed. You saw an effect in Paris in the 19th century, but you'd see nothing in every other place. Okay? And then you want to pay attention to sort of all of these different interventions are not quite the same. Moving intakes to deeper water is not the same as a collection of interventions that separate water and sewer service. Okay, so I'm going the wrong way. Okay, so the question is, why is it that we are finding, does anybody have any idea why we might be finding all these different effects? Like, why would the effects of water treatment, right? Why would the effects of having access to piped water or water treatment be zero in Morocco, right, but not be zero every other place we look? Right? Why would the effects of having sewers in your house be positive in Paris, but seem not to be positive in Brazil? Like, what could possibly be going on? All right? Anybody? So first of all, everybody sees that's weird, right? That's not what should happen, right? That seems weird, right? Okay. Why do you think that's happening? Yeah?
Yeah, thank you. I think the initial conditions probably matters, and which also relates to alternatives available. So if you take a community where they don't have pipe water, but there are sachet water, the impact of not having pipe water on mortality will be lower. And also, if the mortality rate is very low to start with,
Yeah.
having improved water quality will not matter much. So
Okay.
the initial conditions, both in terms of the outcome variable and the alternatives to the interventions matter.
Okay, that's exactly sort of what I got to too. So I think that I would put that more succinct. I think we need to talk to some doctors, right? All right. So my plan on the plane ride home is to read up on infectious disease transmission, right? But I think what must be going on, right, is that is like we're not really measuring the thing that we want. What we want to measure is pathogen exposure. Right? If you're thinking about public health, what you want to measure is pathogen exposure, right? And for the purposes of pathogen exposure, if I give you piped water in your house or chlorinated water in your house, what's going to matter for the improvement is what was the alternative, exactly as you say, all right? And will I see a big improvement if, depends on how sick people were before. All right, so I think that the answer is that we can expect big impacts on public health in places where these innovations are going to reduce the pathogen load. All right, so in a place like Chicago is, and I think also Lagos, right? Chicago's like the flattest place in the world, right? You go 8 miles, there's 8 feet of vertical rise. 12 kilometers, 2 meters. Right? It's like the flattest place in the world. It's really swampy, right? And so you have all of these people living in this really flat, wet place. They're drinking water out of wells in the late 19th century. They don't do this anymore. Late 19th century. And so when it would rain, everybody's cesspit would overflow, right? And where does it go? It goes in their wells, all right? And so in Chicago, you needed either piped water or sewers, right? You can't run sewers without piped water because it's not practical. You can't carry that much water, right? So once you get piped water in place, you should get most of the public health benefit, all right? And I think that the thing that explains a lot of this heterogeneity across all these studies, all right, is that the initial conditions, exactly as you said. All right, and I'm running out of time, sorry. Okay, so now sewer interventions in cities. All right, so there's really just, I've showed you public health is important for cities, infrastructure is important for public health. The rest of that syllogism is infrastructure is important for cities, all right? So I'm going to actually show you that last step directly, okay? So there's not very much on this, all right? So the Allison and Golden paper, the one that looks at the water and sewer construction in Boston, right, as sort of, at the very end when everybody's tired, right? They look at how population density and demographics vary, right? And they find very small effects, right, in Boston in the late 19th century, right? But big confidence intervals. They're really not set up for that, and so they can't do it very well, all right? In one of my papers, one of my papers, we're looking at what happens to land prices in 19th century Chicago when we build sewers. We find that land prices double. Right, when a parcel, right, and we have sort of quasi-experimental evidence, there's a little policy, there's a little policy discontinuity that we're going to exploit, and that suggests that having access to sewers doubles land prices, right? Land prices double, what should happen, what should that tell us about the way the land is used, right? What's going to happen as land gets more expensive is people substitute away from it, and therefore population density goes up. All right, so if you see land prices double, we expect that density should be a lot higher in those places as a consequence of sewers, right? And then in this paper here, which I'm going to talk about for the rest of my time, right? Increasing, if you look at a census tract, right? And you manipulate the share of households that have sewers, you increase it by 1%, population density goes up by 6%. Okay, so that's a really big effect, right? And then this one is, it finds that living near sewer construction projects increases sickness and accidents, all right, which is sort of kind of related to these other things, right? So this is the final step in this logic that I've been laying out for you. Public health infrastructure, public health affects the development of cities, like the extent to which people make each other sick is first order important for the density people are willing to tolerate. Public health infrastructure affects public health, and then finally the public health infrastructure is going to affect the physical organization of the cities, right? And here we are. All right, so the question that we're going to ask in this paper is, how does the population density of a census tract vary with the share of households that are connected? Okay, what's the first order problem that you have to deal with? Like, if you want to answer that question and live through an applied micro seminar, what do you have to do? Right, what is the question that you have to settle for people before you can answer that? Right, it's, why are sewers built in those places, right? Are the places where sewers are built different from the places that they are not, okay? So that's the sort of central econometric problem that we have. If we want to establish that sort of a causal relationship between the availability of sewer access, the availability of sewers and population density, we have to somehow convince ourselves that the places that the places without sewers are the same as the places with, except for that intervention, okay? Right, so to do that, we are going to rely on sort of wastewater engineering 101, all right? So sewers work on elevation, right? You need 1 foot of rise for 200 feet of horizontal, or else all of the solid material settles out of the waste stream and blocks your pipe, okay? Right, 1 foot of 200, can anybody ever work on a landscaping crew, right? 1 to 200 is flat, okay? So if you have a soccer field with you will not notice a grade on it until you get to about 1 to 70. Okay, so 1 to 200 you can't see. So what we're going to do, which means that these very small deviations in grade, these very small changes in grade, are super important for sewer construction. We're going to find places where the grade changes, right? And when the grade changes, your sewage doesn't drain downhill anymore, right? And so you can't put your sewer on the other side of that grade, on the other side of that ridge, right? So we're going to compare as places on a drainage basin. Here, let me just show you the picture. Okay, so if this is a high spot, right? So if this is a feature of the geography, which is a little bit higher, right? Then what should happen when you cross that? What should happen when you cross that is it gets a lot more expensive to build sewers on the other side. To build sewers on the other side of that line, you have to somehow get the sewage up back to your side of the hill where you have your facilities, all right? And that's going to be a cost shock. So when you cross these little features in the terrain where the grade changes, that can be really important for sewer construction, right? Which is what this figure is supposed to show, right? So what I need to do is I need to get some empirical analog of this figure. So this is going to be what I want to think of the organizing idea for here is a drainage basin, right? A drainage basin is a bit of territory where if you pour a pitcher of water anywhere in that basin, it all ends up at the same point. It's like a bowl, it's a basin, okay? A drainage basin divide is a line on the ground where if you straddle it and you pour water on 1 foot, it will not drain to the base, into the basin, it'll go somewhere else. If you pour on your left foot, it goes into the basin divide, all right? So that basin divide is this point here. Right? And what I want to do is I want to compare the availability of sewers on the inside, where you can drain downhill to an existing facility, to on the outside, where you can't. Right? And what I think should happen, all right, is I should see a decrease in sewer availability when I cross that line, and like we do. Okay, so I was sitting in my office in Providence, right, looking at census data and GIS maps from all over the world. You can actually see this, okay, which is like, I didn't think it would work, but it did. Okay? All right, and then we have, remember, and these features, they're not cliffs, right? They are a couple of feet of elevation. They're things that you can walk over. So having told you what a drainage basin divide is, okay, how many of you can think of where there's one near your house? Right? Okay, so like I live pretty near to a creek, so I know that there is a basin divide somewhere near me. I have no idea where it is, right? And I look for it, okay? All right, so why is that important? That means that I can't tell places on one side. I'm looking for it, right? I can't tell places on one side of a basin divide from another, okay? Why is that just awesome? Right? It means the places that are on one side are the same as the other in every other aspect that I can see. Okay? So that if there is a difference in sewer access because they're on one side of this basin divide or the other, that's the only difference. Okay, so that's like a perfect natural experiment for looking at the effects of sewer access on the way these places develop. So that's the thing we're going to do. Okay, so here is, so the trick is to turn this picture, is to get some empirical analog of this picture. I have 10 more minutes? 15. 15? Okay. All right, that'll work out. All right, so I've given a seminar on this a number of times, right? And at the end, I will have somebody walk up to me and say, what is a drainage basin? So does anybody want to ask me what a drainage basin is? Let's get that out of the way now. It'll go a lot better. Yeah.
How many drainage basins are there?
In the world, they're big. I'm going to show you a picture. I'm going to show you a picture, all right? And so the answer is they're often large. Sometimes they're drawn by software, so sometimes the software does funny things, but in general they're large. Okay? Anybody else? Yeah.
You've got a big, perspective, it's a parallel issue I just wanted to touch on, stormwater drainage, right? We've got a massive problem in South Africa of the two running into each other.
Exactly. Yeah.
Are they similar basins and?
They're exactly the same. It's exactly the same logic. All right.
Have water engineers been doing this for 100+ years? Like figuring out the stuff?
3,000.
Okay. Because you said using a computer. I was like, well, how
No. So
how did they do it back then?
So no. Is there anybody here who works for the sewer district? No. Okay. Like if you talk to anybody that works for a sewer district, they'll say, oh yeah, of course. Okay. I'm using GIS software to do this all over the world, right? But like the people that do sewers have been doing this for 3,000 years, all right? They just can't do it for the whole world all in one go, all right? Okay, so what I need some empirical analog of this, all right? So so what I just showed you was sort of a cross section of a ridge. Right now I'm looking down on this thing from the top. So there's going to be some central business district, right, which I will get from UN data on cities, all right? And there will be an area, a basin, and anytime a drop of water falls in here, one way or another, it ends up at some point in this basin. Not at the CBD, it'll be at the lowest, whatever is the lowest point on this will be the pour point for this basin, right? Everything that falls in here will end up at whatever is the pour point for this basin, okay? What I'm going to do is I'm going to make little strips that are orthogonal to the basin divide, all right? And look at what happens in those strips. Those strips are going to be the analog of this thing, all right? So what I'm going to do is each of those strips is going to be a replication of this figure, right? And what I will do is I will find on average how much does sewer share drop when I cross the basin divide, and I will compare that to how much does population density change when I cross the basin divide, and that's going to be my estimate of the effect of sewers. All right? All right, so that's the logic for this thing. All right? Now, so the data that we're going to use for that is the UN cities data is a census of all big cities, right? These are all cities of 300,000. We are sure that they all have sewage treatment, right? All of these cities somewhere have some sewage treatment, have a sewer network, all right? And we know where the center of the city is. So this is going to give us, what this data is going to give us is the location of these points, right? It's going to give us the location of a bunch of points where we're sure there's a sewer network, right? And then we can use the GIS data to draw the basin divide around them, okay? Then we will make a whole bunch of little strips, right? And each of these strips will be a replication of that figure that I just showed you, and that's what we're going to do our econometrics on. Okay, the strips that I just showed you are 4 kilometers long, 2 kilometers inside, 2 kilometers outside. The basins are sometimes really big, right? And so if the basin gets more than 75 kilometers away from the center, we just start throwing that away. Okay, we have data for Brazil, Colombia, South Africa, Jordan, and Tanzania. Okay, the sewer data, right? The part of the reason that sewers are not studied is data is really hard to get, right? Sewers are old, underground, kind of yucky, all right? And so those are all things that make it hard to collect data, okay? It turns out that many censuses, particularly in developing countries, say, is your house connected to a sewer? Right? And so if I can get that data, that just saves me a world of trouble, all right? And so that's what we did. So in Brazil, is the bathroom or toilet drain in your house connected to the public sewer system? And so on for all of these countries, right? What that means is that we can calculate the share of households in each census tract that is connected to a sewer, okay? And that's going to be our treatment, okay? So what's the problem with that? What is the problem with that? Our treatment variable is the share of households connected to a sewer, right? Anybody like who goes to applied micro seminars who's starting to get hives right now? No? Okay. So the problem with that, is that when you start thinking about these quasi-experimental designs with continuous treatments, the econometrics around that is horrible. Okay, so this is something that urban economists have been doing, including me, have been doing for a long time. But when you start doing these quasi-experimental designs, instrumental variables estimation is coming, right? With continuous treatment variables, the econometrics around that is really terrible. Okay, and so we're going to have to deal with that. And I will probably not have time to talk about it, but there's a lot of that in the paper. Okay, so who's heard of local average treatment effects? Put your hand up. Okay, so local average treatment effects really don't make sense when you have continuous treatments. So in case you haven't figured that out. Population, density, income measures, all the other incomes all come from the census. So the census data, because it has this sewer question, because we put it to maps, everything is easy. Okay, so here is these drainage basins. So this is light, the gray is lights at night. So this is my CBD for the city in Brazil, right? This is the thing that corresponds to the oval, all right? This is the basin that contains the center of Cascavel, okay? So this is the empirical analog of that figure. What I'm gonna do is I'm gonna look at slices as I cross the border, all right? And see what happens to sewer access, all right? So this is the basins, all right? It shows you where the CBD is. Now I wanna do this, show you what sewer access looks like. Right, so this is the same figure, right, where I'm giving you a heat map of sewer access, center of the city, okay? Here is, I'm gonna blow up this area, right? What happens when I cross the basin divide, right? All right, it's like this picture is just worth $1 million to me, okay? All right, so you cross the basin divide and boom, no more sewer access. Right, this is just exactly what I showed you in in that little drawing. Okay, so we are going to do this all over the world, all over those 5 countries. Okay, so we have 90 countries, we have 90 cities in 5 countries. We're going to do this picture, all right, and we're going to look at what happens to sewer access when you cross basin divides. Okay, we're going to restrict, this is 2 kilometers inside, 2 kilometers outside. All the gray dots are census tracts. The unit of observation is a census tract. The gray dots are centroids. All right, so it's that's what we're going to do. All right, if we do that, yeah, 9 minutes. Okay. I don't remember how much I have to go. All right, so I'm going to show you our estimating equation just because that's important. All right, so each of those little strips we're going to call a radial bin. All right, a tract is going to be I. All right, so each tract, each of these little dots is an I. All right, and there will be these strips 2 kilometers wide. That'll be a K. All right, so this is sewer share. That's our treatment. This is our outcome, which will be the log of tract population, and then the distance to basin divide. So who can think of a problem with this research design? Okay, so if you look at this picture, okay, right, or maybe even look at this one, like what's the problem with this research design? Okay, what am I thinking about? What I'm thinking about is variation in sewer share as I travel radially from the city center. Okay, what could possibly go wrong with that? All right. Anybody? So what do we know, what do we think happens as you travel radially from the center of a city? Density drops, okay? So that's exactly what I'm looking for, though, is for density to drop, okay? So what I really need is I really need to worry that I'm just picking up this sort of secular drop in density that happens because we're moving further away, all right? So for each of these strips, right, I'm going to look at variation in sewer share conditional on distance to the center. So every one of these strips is going to have its own intercept and slope with distance to the center for each of these, and I'm just going to be looking at the change that happens as a consequence of crossing the border. All right, so I need to write down a regression specification that allows that. Everybody got that? Any questions? Okay, so I need to write down the math that allows that, right? And this is it, okay? The sewer share, right, has got the profile of sewer share. So in my plot, I showed you a line of sewer share goes like this. I want to write down that function, the thing I'm going to estimate, all right? So what this is this is the intercept of that line, right? This is allowing it to have a slope as I travel from left to right for each of those different replications of that figure, right? And then I'm going to let the slope, the intercept and the slope change when I cross the border, okay? And these changes, it's the changes that happen when I cross the basin divide. That's going to be the thing that I think is the quasi-experimental manipulation of sewer share that I'm going to use to identify the effects of sewer shares on outcomes. Okay, everybody got that? That's a lot of jargon. Is anybody not familiar with that? Like if you didn't know that jargon, now's your chance to ask me. Okay, so what we're thinking about is we're imagining we're throwing all of these, we have a basket full of census tracts and we're going to throw them up in the air, right? And let them land, and some of them will drift down inside, some of them will drift down outside, right? So we're distributing them at random across the border, okay? But as soon as they land, they're different distances from the center, and that's going to cause problems. So I need to fix that problem. But once I've done that, right, once I've done that, then the crossing the border, right, the crossing the basin divide is going to give a bump in sewer share, and I can use that to think about the effects of sewer shares on population density. Right, and that's the logic here. The problem is that this is a continuous treatment, and that creates a lot of econometric problems that I won't have time to talk about now, right? So, but as stated, this is a straightforward two-stage least squares estimation. Sewer share is a function of my instruments outside and outside interacted with radial displacement, and this is going to give me my treatment effect, so which is going to turn out to be 6%. So when I bump up sewer share, when I give 1% more of households in a tract sewer access, right? On average, the population density in a tract rises by 6%. Okay, everybody understand that number? Okay, now, how do we think about how big that is? Right, so let's do an experiment where we add 1% of sewer connections. Right, we're going to take some city, we're going to add 1% of sewer connections, right? What should happen? Population should go up by 6%, right? Is that big? Well, we can compare that to the effects of some transportation innovations, some transportation road infrastructure from the literature, right? So Nate Baum-Snow, what he did is he looked at what happened to population density in the centers of US cities when you built a radial highway through it. So a highway that started in the center and went to the suburbs. If you built the highway between 1950 and 1970, what happened to population density by 1990, right? So it fell by 9%. Okay, so a radial interstate highway. If you haven't been to the United States, the interstate highways are bigger highways than the highway that connects us to downtown, right? They're at least 4 lanes, often more, and you can go 70 miles an hour no matter what, except at peak hours, as Gabriel told us. All right, so those highways, those roads, and they reshaped US cities, right? they look like they have small effects compared to, they look like they have about the same effect as adding 1% of sewer connections to a center city, okay? Which suggests that like sewer access is about as important for the geography of cities as is, as our important innovations, as our important improvements to the transportation network. Okay. Any questions? Yeah.
Yeah, a couple of things that worrying me, so maybe you can make
Yeah.
me worry less, is your first example early on was that people can't actually know that there's a sewer there or not. You said like,
Well, they know if it's in their house, right? So the treatment here is, do you answer, yeah, I'm going to change the sewer network in such a way that 1% more of households answer yes to the question, does your house have a toilet connected to a sewer?
okay.
Right. So people know, right? So people, like, I think people know, I don't think there's any doubt that people know if there's a sewer system in their network, in their neighborhood, right? The question is, for people like me, it's hard to find out, right? It's hard to find out where the sewer lines are, when it was built, who's connected. It's very hard for me to see, but if you live in a house, I don't think it's hard to know at all. I can't imagine living in a house and not knowing if it was connected to a sewer.
Okay.
Okay?
And the follow up there was, is it not also got to do with, because the final outcome, what I'm understanding, is around population density, right?
Yeah.
Is it not got to do with zoning laws, etc., that actually allow for it or don't allow for it? You know, which way is it kind of working?
Okay, so-
is it not as just simple as that the planning happens
Okay,
and they
so-
allow a certain amount?
Exactly.
Of density?
Okay, so you're doing exactly what you should do, all right, in an applied micro seminar, right? So what you're saying is, I am going to find some unobserved thing which is correlated with your treatment, your instrument, and the outcome, right? So it might be, so now, I'm in trouble only if zoning also varies at these basin divides. So the whole object of comparing things across basin divides is to respond to any question like that you can come up with, right? Which is that you have to find, in order to compromise this research design, you have to find something that affects sewer, that is correlated with sewer share, varies at a basin divide, and affects outcomes, right? So what's the extra condition that you need, right, for that objection, zoning, right, to be a problem for me? Is that the zoning has to vary at basin divides too, right, systematically, all right? And that is something that you would be concerned about if you thought that for example, administrative boundaries also follow these basin divides, which seems like a reasonable thing if they're important geographical features. Okay, we checked and they don't. Okay? Thank you.
Thank you very much, Prof. Turner. I wonder if anyone expected this morning that sewers could be so interesting.